Okay, pre-cal babies, we are at the bottom of page 3 of our notes, and we're going to talk about how to find values algebraically and graphically in a function. Another way to think about this is evaluating functions. Okay, so let me just write that here. I think that's the title of the video. Okay, so if, for example, we are asked to find f of 2. In other words, when x is 2, what is the y value? What's f of 2? So that means we're finding the value of y when x is 2. So let's say we have a function f of x equals 1 minus x squared, and we want to find f of negative 1. In other words, I've got an ordered pair that consists of negative 1 and something. So I'm finding the something. I'm finding that y to complete my ordered pair. So this is how we do it algebraically. We are going to simply substitute in values, and then we are going to find the y. So here's what I'm going to do. Notice there's an f here, and there's an f here, negative 1 here, so I'm going to replace that x with negative 1. So f of negative 1 equals 1 minus, and since this is an x, I'm also going to substitute the negative 1 in there. But it is very, very important. I cannot emphasize this enough to you. You need to pay close attention here. See that squared right there? You have got to put this in parentheses. So the negative 1 goes in parentheses so that when you square it, you square the whole thing. So I've got f of negative 1 equals 1 minus, well, negative 1 squared is positive 1, but since this negative right here carries through the whole way, you're left with 1 minus 1, which is 0. So your ordered pair is negative 1, 0. That means that when x is negative 1 in this particular function, which you can tell 1 minus x squared is a parabola, it's a quadratic function, that means that at negative 1, the y value is 0. So that's what this is all about. Okay, so let's try this one over here. Now we've got a function that's a little more is going on, but again, it is also a parabola. So if we will look at what we're finding here, find f of negative 2. So everywhere you see an x, we're going to put the negative 2. So let's start with this first f of x. I'm going to find f of negative 2. So that equals 4. Use your parentheses to substitute things in. Plus 2 times negative 2 minus 7. Okay, so I've got 4. So f of negative 2 equals 4 times negative 2 squared is positive 4. Plus 2 times negative 2 minus 7. You could have done that. I'm just trying to make sure all my steps go together. So 4 times 4 is 16. 2 times negative 2 is negative 4, and then minus 7. So now I am going to just combine like terms. I'm just going to add my numbers. So 16 minus 4 is 12. 12 minus 7 is 5. Okay? So your ordered pair here is negative 2, 5. So that is how we evaluate functions algebraically. All right, so now what I'm going to do is show you how to evaluate them graphically. This is actually a little bit easier. So if you will look at this first example right here, find f of 3 and f of 5 for the graph. So if you will look at this right here, f of 3, well, I want to know what y is when x is 3. So I'm going to find where x is 3 on here. Well, this is the x-axis, this is the y-axis. So x is 3 right here. Okay, ooh, that line is not the greatest, but that's okay. All right, so I'm going to actually tidy that up a little bit. So I'm going to find where the graph intersects 3. So that's going to be right here. So that ordered pair is go over 3 and down 1, 2, 3, 4. So that is a negative 4 right there. That's that ordered pair. And then I'm going to find f of 5. So I've got an ordered pair of 5, and I want to know where the y value is. So at 5, I want you to notice I count over 1, 2, 3, 4, 5. So that's that right there. Well, this graph would be at 0. So 5, 0 because it's on the x-axis. But pay attention to what's happening up here. Anytime you see an open circle, that means that value doesn't exist right there. So we do have a value, a y value for when x is 5 here, but not up here. Okay, so let's do the next example. We have two functions here, and I haven't labeled them, but I need to do that for you. So let's see. This curvy graph, this one right here, this is going to be the f of x, and the one that's got straight pieces, this one right here, that's g of x. Okay, so we'll use the curvy graph for the f values and the straighter graph for the g values. So let's look at f of 4. So I'm looking at the curvy graph. So let me highlight that so you'll know what I'm talking about. So this is the graph I'm going to use for the f problems. Okay, so f of 4. So I come over here to 4 and I go up right here. It intersects right there, so that is a 2. Okay, so I go over 4 and then up 2. That's where that graph is, or that point is. F of -6. So I go over to -6 and up. It's got the same value, 2. F of -10. I go -2, 4, 6, 8, 10, and go up here. That is going to be 4. And then f of 8, I go over 2, 4, 6, 8, and up all the way to right here. And these count 2, so that'd be 2, 4, 6. That's where that is right there at 6. Okay, now it's time to use the other graph. So let me get another highlight color over here. So for the G, I'm going to use this straight piece of graph right here. So g of 0. Well, at 0, if you will go up right there, that's 4. And g of 6, we're going over and then down 2, 4, 6. So that's -6. And then g of -2 is right here, and that's going to be right on the x-axis at 0. So that's how we evaluate graphically, and then of course we evaluated algebraically.